Hey guys. So the last two topics, so this is the homework video for number 6, and this is part 2. So this is the last two topics. And so the first thing I want to talk about is topic ERF, which is we're starting now to solve quadratic equations. So in the past, before, you were solving linear equations. And so the idea with linear equations, obviously, if you have two, something like 2x plus 3 equals 9. So it's like you're trying to figure out what x is by isolating it. And so this is where you had steps like subtract 3 from each side, right? So you're getting the x by itself, and then you divide by 2. So the first way we talk about, so solving quadratics is not as straightforward as linear. So the reason we start with linear in pre-algebra is because it's the easiest one to work with, and then quadratics is, more challenging. And so part of the reason is because quadratics has typically 2 solutions, because it has a squared term. And so when you have like a degree of 3, where the exponent, the highest exponent is a 3, then you'd have 3 solutions typically. And if it was 4, you'd have 4 solutions. So since my term for a quadratic is I have a squared term, since that's like the whole idea is I have a squared term, that means that I'm going to have 2 solutions typically. And the reason I have 2 solutions is because of this setup. If d squared equals 36, one of the things, we talk about is opposite operations, and things like, addition, subtraction, or multiplication and division. Those are opposite operations. So another opposite operation is an exponent of 2 and a square root. So squaring something and square rooting something are opposites. So in this situation, if I want the d here to be alone by itself, to isolate it, I need to get rid of this exponent that's here on the outside. Oops, I need to erase it. So I need to get rid of this 2 that's on the outside here. And the way that I do that, the opposite, is to take the square root. And just like when I was working with linear, whatever I do to one side, I need to do to the other side. So if I take the square root of d squared here, then I end up with just d. The same way that if I take 5 squared, right, 25, and then take the square root of it, I end up back with the base again, the 5. If I square and square root d, then I end up with just d. The issue is, though, is that when I'm taking the square root of 36, obviously the square root of 36 is 6, right? Because 6 times 6 is 36. But that's not the only solution, because really -6 times -6 is also a positive 36, because 2 negatives are going to cancel to make a positive. So not only could d be a positive 6, d could also be a -6. And one of the ways that you can write that, if we were writing this down on paper, would be to say d equals plus or minus 6. So that's the way to write both answers at once, if you were writing it down with pencil on paper. Obviously, though, if you look at the way the answers are set up for IXL, you're just going to type in a positive 6 and a negative 6. So r squared equals 100 would be the exact same idea. So if I'm looking at r squared equals 100, then I'm going to take the square root of both sides. And I end up with r equals positive 10 or r equals a negative 10. So pretty straightforward. They can add steps in here. So like you'll notice with this one, I have the j squared, but I'm subtracting 59 from it. But the good news about this topic is that it works very similarly to square roots. Or I'm sorry, it works very similarly to how linears work, just with that extra square root piece. That's the only part that's really different. So if I was trying to isolate j squared, I still view it like I have 2 sides. I still need to get it by itself by doing the opposite here, adding 59. So I end up with j squared equals 121. And then if I take the square root now of both sides, then j is a positive or a negative 11. So same idea, if I had a coefficient out front, I would eventually need to divide that out. So 2r squared minus 95 equals 3. So I'm going to add 95 to both sides, just like I would with a linear equation. I'm trying to isolate this r squared term. So I'm going to add 95. And I'm going to divide out the 2. 49. And then if I take the square root of both sides, I end up with r is a positive or a negative 7. So I don't think it's too hard. I feel like it's so similar to linear that I'm sure you'll be fine. There are a couple of things to be aware of. They have a little bit of a different setup for a couple of these. If I look at something like f squared equals negative 15, based on what I just said, I would take the square root, right? And this would turn into f. The problem here is that there is no way I can get a negative sign underneath, because I'm either going to be doing a positive times a positive, right? Because it's going to be the same number multiplied twice, or I'm going to do a negative times a negative. But there's no way I can do a positive times a negative in order to get a negative sign, because then these are different numbers. So then I'm not squaring it after all. It's not squared. Make sense? So this has no real solution. You can't take the square root of a negative number. Yeah. Because when you get to algebra 2, then you'll learn about something called imaginary numbers. And that is where you can start taking the square root of negatives. Notice that here it says real solution, because there is no real solution. There is an imaginary solution. You just don't know about it yet. So someday you'll find out. And then this one I wanted to show you just because it's the only other scenario that could happen. X squared plus 74 equals 74. So if I were to subtract away the 74 here, 74, then I get x squared, and these 74 minus 74 is just 0. So if I go through and I take the square root, this is really the only situation like this where you're going to have 1, because 0 isn't positive or negative. So it's just going to be 0 times 0. So my answer here is just a 0. All right. Next topic is very straightforward. It's going to be very useful soon when we start factoring to solve. So if you have no middle term, then you can factor by using square roots. So I just want to point that out. Let's see which problem. So if we look at something like this, number 4, the reason that you can factor using square roots is there's no middle term. That's the only way it works. The problem is if you have a middle term, then you can't use that strategy anymore. So you have to do factoring. And we're not going to do that yet. But what we are going to talk about is this thing called a zero product property. So this is a rule in math. That's why it's called a property. And really all it says is if you're multiplying two numbers together and it equals 0, then one of these numbers must be 0. So either v is 0 or v plus 6 is 0. Because if you're doing something times something equals 0, one of the numbers, the somethings that you multiply together, must be a 0. Right? Because that's the only way to make this multiplication problem equal 0. V times v plus 6 equals 0. So you're saying either v equals 0 or v plus 6 equals 0. And so the idea is to solve these two things. And you'll notice here it says what v would be. In this case, v is 0. So one answer is that v is 0. V plus 6 equals 0 means that if you subtracted the 6 away here, you'd get v equals negative 6. So that means that v could also be negative 6. So either v is 0 or v is negative 6. That's the way to make this math problem multiply to equal 0. Either you're going to have 0 times 0 plus 6, or you're going to have negative 6 times negative 6 plus 6. Make sense? So 0 times this would equal, so 0 out front multiplied by this number would equal 0, or negative 6 times this, which equals 0. So this totals up to 0. So it'd be -6 times 0. Basically, you're just trying to figure out what could you plug in here to make a 0. So let's look at a different one. So this one's saying h times 5h plus 4. So I literally come over here and say either h equals 0 or 5h plus 4 equals 0. And then I solve each one. This is obviously the answer here. I don't have to solve anything. It's just h equals 0. But here I can subtract 4 and then divide out the 5. So that means h could also be -4/5 in order to turn this into a 0. Here I have two binomials. So notice that this looks a lot like what happens after I factor. So either h plus 1 equals 0 or h plus 8 equals 0. So if h plus 1 is 0, then h is -1. Or if h plus 8 equals 0, then h is -8. So these are my two solutions. And then the last one, I chose one that was just a little bit more complicated, but same idea. So I have 4m plus 9 equals 0, or 5m minus 2 equals 0. And then I'm just going to solve those two separately. So -9. So m is -9/4. So that's one possibility. Or m could also equal 2/5. So -9/4 or 2/5. So we were just doing a lot that had answers from the last problem that were whole numbers. So from the last topic that were whole numbers, you can see that this one lends itself a lot of times to more fractional answers. So, okay. Good luck. Let me know if you have any questions.